Hello, good afternoon. This is Junichiro Horikawa. This is supposed to be the weekly live stream for Houdini Algorithmic Live. This is a tutorial live stream for Houdini, which I've been doing weekly, but for this 2 weeks I've been a bit busy doing all sorts of works and workshop. Wasn't able to do the live stream, so here it goes. It's been around 2 weeks. Okay, so I still want to continue doing this, so let's do this. So the topic for this week is to create a strip out of an input geometry, bunch of strips, wrapping the geometry like this. You can also change the resolutions by changing the resolution of this instant mesh. And another things that I want to implement today is to kind of be able to peel these strips procedurally using KineFX like this to give a little bit of an interest on this strip encoding. So that's my plan for today, and let's do this, shall we, from scratch as always. Okay. Hello everybody. So for today it's going to be let me first tell you the base workflow for today, how I'm gonna implement this. So first of all, what I'm going to do is to prepare an input geometry as always, obviously. And next, what I'm going to do is to create a quad mesh out of a geometry, input geometry, using a plugin from SideFX Labs called Instant Meshes. This is an algorithm developed by a researcher in ETH, Switzerland, which will enables you to create a quad mesh like these, a nice quad mesh like these from your input geometry. And I am going to use this as a base to create a strip of quad faces. Okay, then I'm going to create a flow using for each loop to create a bunch of strips out of these quad mesh like these randomly. And then finally I'm going to create some code to be able to unroll the surface, unroll the strips using KineFX procedurally. As you can also change the angle, how much you want to roll, and probably the timing as well, like that. Okay, so that's my plan for today. Hopefully all gonna be interesting. Alright, so I am going to create this tutorial from scratch. I just wanted to show you the base process, what it's going to be like, because this is probably gonna be a bit long to explain. But as always, I always explain it from scratch. So, hope you'll be able to stick with me. Alright, so as always, let's start from geometry node. Then, first thing first, we need to prepare geometry in order to create a stripping. strips, quad strips. So any geometry is fine. I'm going to use a test geometry which is complex enough to test out. If it's just a sphere box, maybe that's too easy. That might not have many conditions, unexpected conditions, so it's probably better to use a rather complex geometry like these. You have thin surface like here, you have a concave area here, and so on. But anyway, I still need to fix this geometry a little bit because I want to make it as a one continuous solid geometry, and I am not sure if this is a solid one, especially inside the mouth or where the eye is. So I'm going to make sure that this is going to be the solid closed mesh. So what I'm going to do is to create a mesh out of VDB. So first I'm going to convert this into VDB. With some high res, and I do see some edges here, so maybe it might be better if I do the subdivisions just before convert it into VDB, so that it gets a bit more smoother. Okay, then make this back to a polygon to make it as a solid geometry. Also make sure that you check fill interior so that all the volume is going to be, the volumes inside this geometry is going to be filled, so that's it's going to become a solid geometry. Then convert this back to a polygon. Okay, I guess this will be okay to test out in order to convert it into a quad mesh. So let's do this, and let's also create a group node. Oh, you can't not hear me. Let me see if I can raise up my volume. How's this? Can you hear me? My microphone is pretty close to my mouth. Alright. Where was I? So I'm going to make a group node for primitive to say this is geometry or geo. Okay, let's cover this with the group. Okay, so what I want to do next is to convert this mesh into a quad faces. So in order to do that, you need a SideFX Labs being installed in your Houdini application, which you can do this from here. If you go to the launcher, you'll see you can download or install the SideFX Labs based on your version of your Houdini. Okay, I'm using 19.5, so I have installed this one. Should be able to use it. And if you have installed it successfully, you should see those icons on SideFX Labs tab from somewhere from here. Okay. Now, if you have it installed, you can use this Labs Instant Meshes, which you cannot really use it in default if you are using Macintosh. I mean, if you're using Windows, that's not a problem, because you have this instant meshes in a specific folder. But in terms of Macintosh, this is not pre-installed, so you have to download it by yourself. So you should go to the link, you should click this button to open up the link where you can download the instant meshes application, which is this one here. If If I'm using Macintosh, you download this. If you're using Windows, you don't really need to do anything. Okay. Then if you have installed Macintosh, then you have to place that instantmeshes.app into a corresponding folder, which is placed in this directory. Now you can check where that is by going into a window, HScript export, paste that expression, paste it, and you should be able to see the corresponding directly for that. So then you can now go to that place by open up the go to folder, finder message, and then there you go. You can open that folder, and I have already copied the applications inside this folder, which is called instantmeshes.app for Mac. If it's Windows, that's exe. If it's Linux, something else. Then once you copy that file, you have to go to that place, go to that application using clicking this directly button, and inside instantmeshes.app, contents, macOS, and there you go. You choose this one. Now you should be able to see the quad mesh being appeared. Now it also has the original mesh being covered. You also have the original mesh, and you also have the quad mesh, so you don't really need the original mesh be merged. So I am going to delete that by using this group that I created. If you're using Windows, I think the version for the instant meshes is 2.0, which doesn't really have the original mesh, so maybe you don't really need this process. But anyway, I'm using Mac, so let's just delete it. Now you are good to go with this quad mesh. Okay, looks nice, and you can change the resolutions of this quad mesh by changing the number of polygons right here inside instant meshes, like that. And the parameter I would like to use for this one is I mean, any parameter is fine. It's not much parameter you can choose. Either you want to make it quad dominant, which enables you to create also a triangles, and sometimes a how do I call this, a polygon with 5 faces, 5 edges. Okay, if you only want quad faces, you should check this out. You should check this off. In our case, we want to create a strip from a quad faces, so I guess it's good to go without this checked on. And deterministic, not really sure what this do, honestly. Looking at the result on and off, can't really tell the difference. Okay, so I guess I'm okay either way, so I'm gonna make this checked on for now. Right, so I guess it's also a good idea to have this being globally parameterized so that you can control this later. So let's give a null node. Try to copy that parameter. Here. Okay, poly count is fine. Okay, now I can access to this poly count from this controller. Okay, looks good. Let's go a bit low res for now, so that I can test out quickly. Though, if I make this low res, I have a little bit of problem on this ear because the ear is a bit thin. So let's make this a little bit thicker by modifying the VDV a little bit. So I'm going to use VDV reshape SDF to dilate. Dilate means inflate, which will make the geometry a little bit inflated. We'll make it a little bit thicker. Now I might going to have some problems where it has a small connections like these. So let's also fill that up. Just get rid of the mouth by making this go, or making this reshape a little bit smaller so that you can have enough opening like these. Maybe that's good. Yeah, maybe this could be a good condition to test out if this is also going to work or not. Alright, so looking at the polygon, okay. Good enough for testing. And I want to make sure if this is like one continuous solid object. So I'm going to check that by using a connectivity node for primitive. And you can check if every node is connected by looking at the geometry spreadsheet, looking at the primitive tab, and if the class is more than 0, then that means you have like separate geometry. But if the class is all 0, then that means everything is connected. So it looks good. But just in case something class might be more than 0, I might need to give a little fixed code in order to make it as a solid geometry. So let's create that kind of situations by making this a little bit fatter, like that. In this case, I might going to have an inner geometry, yeah, like that. So right now it seems like it's a closed geometry, but if you go inside, if you open up the geometry using clip, you somehow see another geometry inside. Yeah, like that, where the mouse is. So you want to get rid of this one for later process. So in order to do that, I'm going to measure the area based on the connected geometry based on class, which comes from connectivity node. And then each primitive stores the total area of each connected pieces like this. So one of the connected piece has 13.26 as an area. Another one, where the class is equal to 1, have 0.2. And what I'm going to do is to just get the largest area connection. So in order to do that, I'm going to create a little script right here. And also I'm going to sort the geometry based on sort the primitive based on the area, so that the largest area comes first in terms of the index. Okay, like that. Oh, someone commented, George commented, use labs delete smaller. Didn't know that one exists. Labs delete small parts. Oh, that looks good. Okay, let me try. Let me try again, checking the connectivity. Maybe I can just do this. Oh, maybe I needed it. Not yet, I guess. So I should check with this one. Let me see what I need to do here. extract large pieces. Okay, I guess that's what I needed. Oh yeah, worked. Nice. Thank you. This works out great. Okay, so no script is needed. If you're interested in using code, I could also do this, but let's skip it if it's not necessary. Alright, that's good. So let's just do this. And go to the next step. So I'm also going to calculate the normal at this point, just in case I might going to need this. Then connect this to a null node, which I might going to refer to later. Okay. So Balat said I would like to see it done with Vex as well. So I could also show you how this might be able to do using Vex. So in my case, what I would do, first I calculate the connectivity, calculate the area, and sort it out based on the area so that the largest comes first based on the attribute area, and check reverse primitive sort. Then what you're going to do now, you just get the first primitive class by which comes from the connectivity. This means first primitive in the index. Then if the current primitive inside primitive wrangle class is not equal to the first primitive get from the first index, then just remove it. Now the number of primitive 2104, this one 2100, so it's the same. You are good to go without any small parts. So that's another way, but comparing this one to this one, obviously this is much easier again. Alright. That just in case, as for your reference, maybe the technique could be used for other purposes. Alright, so let's go to the next part. Let me cover this with the network again. Okay, so what I would do now, what I would like to do next is to start creating the strip. Okay, so what I'm gonna do, the way that I'm going to create a strip is recursively going to create a strip. So first thing what I'm gonna do is to choose like random edges or your own chosen edge from one of the primitive from this geometry, such as these edge. Just pick one of the edges, and what I'm gonna do is to simply try to follow a similar process that's used in labs loop from selection. Okay, this labs from selection is pretty cool. What it does for you is to enable you to select the looped quad from selected edge, like that, which is pretty cool. The problem with this one is that problem with this is that you somehow have these cross selected loop like these, and I don't really actually want that. I wanna be able to have only a I don't want to have any like crossing like these. Instead, I just want to have an ending. I want to have some splitting at the corner, this way or this way, right? So one way to do is to create a similar process without using labs form selections by yourself, and try to implement the similar process, but try not to cross the already created section, already created strips, so that you can unroll it later. If not, you can try to use this one instead and create a split where you have a cross. That's another possibility. So I guess the latter process, just trying to use this one and then try to like split the cross part will be easier, I guess. So I might gonna do this, but the way I did it previously is just done it by my own algorithm. Came up with my own algorithm, but that might take some time, so maybe I didn't really tried it before, but I could try to use this one instead to see if it's gonna work. Okay, I have a question. If you wanted to convert these selections into a spline, how would you do that? Meaning to collapse that selection into a spline. Think like taking a bandage wrapped around the head and convert it into a banded of thread or string. Well, I could show you that later. Yeah, I could show you that later. I mean, I am going to do that later for unrolling purpose. Okay? But simply, you just take a connected piece from selected primitive. For example, if you have selected this primitive, then if it's a strip, you know that the connection is the number of neighbor polygon is always 2, 1, 2, okay? And you know where the edge is, where it's connected to the other polygon by looking at the half edge. So by getting those half edge informations, you'll be able to create the line connecting from this to this, okay? And you do the same for all the quads, and then obviously in the end you'll be able to create a thread or string out of a primitive. So that's the way. Okay, hopefully it makes sense. So shall we try to do this from this loops from selections, because this looks easy to use, isn't it? You don't really need to care about the more of half edges by yourself for these connections, so works pretty good. Cool. But we have to kind of solve this kind of situations by ourselves. How are we gonna solve this and so on? Okay. So how are we gonna do this? How are we gonna approach with this strip? Say we have started from this edge, and the strip goes to this direction, and the first strip should be able to go straight because there's still no crossing yet. But then this goes like this goes like this goes like that, goes like that, and then you start to have a cross here. Okay, this is where you want to create a split right here and right here. So in order to check that, you might need to run through the strips one by one to check whether you need a split or not. Otherwise, well, let me just try to get this corner, like the cross primitive, and just randomly pick one of the edges to split, and see if this is gonna work. Primitive wrangle. If not, maybe I'm just going to first of all try to implement by myself without using this one, and later on I can come back to this one to see if there's any other way to do that. So the output quad group is quad loop, so looking at the quad loop, and also where it has a quad loop, I want to split it into a separate geometry, so let's create a split like that, so you can extract the strip, only the strips, like this. Then maybe I don't need this. And then I can count the neighbor primitive by using polyneighbors. Okay, and if the neighbor polygon, the number of neighbor polygon is equal to 4, that means you are at this cross center. Then that's where you want to create a cut or splits to the edge, one side or other. Okay, either this side or this side. Okay, so I'm just going to get the first half edge from this primitive, which you can get it from prim hedge. Num. Yeah. Okay. So let's say this is the starting point and this is the end point for the half edge. Go from this point to this point. So let's say this is the edge that I have just picked here. Now what I want to do next is to get this edge number, which is the next edge is this one, and the next half edge is this one, so you do the next operation 2 times to this edge. So other side edge is edge next, and do the same edge next again to go to the other side. Alright, now I can now get this edge and this edge. And what I want to do next is to give a edge group to each of the half edge, so that I can specify these edges to cusp or a split. So in order to do that, you need to have a point number for each half edge. So I'm going to get the SPT1 from the half edge. You can get the source point using function called edge source point, endpoint edge destination point. Okay, that's for the first half edge, and for the other side can pretty much do the same thing, just change the variable. Now you have one edge with 2 points, another edge with 2 points. You can now set the group to the edge. Let's name this cusp to this edge. The order doesn't really matter. You can start from EPT to SPT1 in terms of the edge group. Okay, like that. Now, hopefully this will enable you to select these edges. Let's see if this is the case. First, I'm going to check again the connectivity to see if this is all connected as one piece, just in case. Right. And after I have splitted these edges, the connectivity should change. The class number should increase. So that's what I'm looking for. Let's see if that's gonna happen. So in order to split the edge, I'm going to use the edge cusp. And the group is cusp. And also check this cut boundary points, which would increase the vertices. It didn't really increase the vertices. I'm not sure if it's going to work, but let's see. Now I have connected the connectivity, and let's see the number of classes changes, and it did. Yeah. So based on the connectivity, let's try to color the pieces and see how it's being distributed. Primitive, random from attribute, class. Okay, so this seems to be the connection. Now this looks a bit weird. But overall looks pretty nice. Okay, you have a little bit of problem here. You also need these split. And here it's okay, so it seems like it's, I don't know what's going on here. Let me check. Oops. So you need to figure out for each of those irregulars, because this might gonna have, okay, so obviously this is not a good condition. You don't really want to have this kind of conditions here. So in order to fix this, what you need to do probably, so okay, here, all right. So this could be the problem right here, where you have kind of a irregular square piece creating a triangle with 3 squares. Most of the time you should create squares with 4 squares, but this one's instead creating triangles with 3 squares. So we need to fix this situations, obviously. So how we do that? But for now, for the other part, looks okay. It's not really a one continuous things, because it's been splitted. So if you want to make sure that if one of the pieces is going to be really long, also covering these crosses, this one wins over these crosses, then you have to calculate it recursively. But that's gonna take a little bit of calculation time, so let's try to go with this approach for now. But we still need to fix this part for sure. Okay, so the condition that I have set here is the neighbor polygon is equal to 4, so this also, the condition also applies here as well, so probably you do have a split since this one is being splitted here, I guess there is a cusp on this edge as well. Let's check by selecting the point, try to move that point. If this is not connected, okay, yeah, then that means you have splitted this edge. So what I want to do next is to try to also split these edges, which is being connected like that. So we need to figure out the conditions of this one. Okay, so in this case, if you look at each primitive, you have 3 neighbors. Okay, and let's see if you have that kind of conditions anywhere else. Like this one, yeah, this one also have 3, this one also have 3, but other than that, I don't see it, so maybe that might be a good condition to test. So let's do that, shall we? I'm going to, after I have splitted the corner, the cross center, I'm also going to try to split the primitive that is connecting with 3 neighbors. And I want to make sure that I am not splitting this part, but just this part, which you can see the conditions that you don't have a other side primitive for this edge. For this edge and this edge, you do have a primitive on the other side, but for this edge, you don't really have the primitive on this side. So I guess there is a rule to be able to specify only this edge to be splitted. So first of all, check if the poly number is equal to 3. Right, then again I'm going to get the half edge just like I did. Randomly. Now what I want to do next is to probably just go over all the edges, 4 edges, because I'm only working on the quad. I know that there's always a 4 edges, so I can just loop with 4 to check all the 4 edges if you have a specific condition. Okay, so half edge is equal to edge next. I'm just calling next 4 times, overriding the original edge, meaning you always come up with a new half edge. If you start from this one, then the next one is this one, next one this one, and next one this one, and you're gonna do this 4 times. Okay. So that you can check all the half edge. Now, in order to check if there is a primitive on the other side, you can check it by getting the next equivalent half edge by calling the function called next equivalent. Okay, so if the half edge for this primitive goes from this point to this point, the next equivalent goes from this point to this point. The order is reversed. Okay, but in this case, where you don't have a next primitive, then if the half edges go from this one to this one, then the next equivalent half edge will be from this one to this one, become the same half edge, okay, because you don't have the other side. So that's the way you can check if there's polygons on the other side. So if half edge is equal to and next equivalent edge, half edge, then that means you don't have any next primitive, so the other side will be going to be splitted. So the splitted half edge is going to be the next half edge of this one. So looks confusing, but if you try to draw it in your mind, it will be easy. Okay. So this should be the edge that I want to split, this one. Then in order to split it, you need to have again the endpoint. So let's get that. Like that. Then finally you can set the group. SPT, APT. There you go. Shall we just check it with the color and see if you have selected the correct edges? Okay, I don't see anything, so maybe I'm doing something wrong. Oh, now I see it. Okay, looks good. I might need to change the name of the edge group. Alright, so looks good. This is exactly where I want to split. Alright, so let's split it. Cusp 2. Okay, now let's try again to color the strip, and there you go. Nicely split it. Alright, so everything else looks fine. I guess I could just continue. Again, I have questions. Will you provide a project file? Yes. After I have finished the live stream, I'm going to upload the file, the very file that I'm creating right now, to GitHub. You can download from a video description page of this live stream, or from the Patreon. This is something I really wanted to learn. Thanks. If you can just quickly go over concept a bit more, that will be perfect, and maybe talk about and alternative approach. Or is it Houdini nozzle? One Houdini nozzle. Hedge next is your own defined variable, right? Well, no. Hedge next is the function defined in Houdini. Anybody can call it. You can check that by going into the vex function page. From side effects, if you search for hedge next, there's a function preserved in Houdini, which you can call to get the next half edge numbers. These half edges are really important data structures for geometries, which you would use a lot if you're going to do the geometry processing using Vex. So you might want to look into these functions. Okay, you could also go to the half edge section here on Vex, where it explains what it really is. in easy manner. Alright, well explained. So now that I have the initial strip, I just want to continuously doing this again and again to the other leftovers, which is these pieces. Okay, doing the similar operations until you are filled with the strip. Okay, this is looking nice, actually. And in the VEX for algorithmic design course, you don't have a lesson on point clouds. I would like to do a lesson on point clouds functions. I guess that's correct. Maybe that's a good topic to go for. Yes, I think I'm going to do that sometime. All right. So let's continue. So where was I? So now that I have these, I think I can just reuse these functions and again recursively to those leftovers. So let's create a for loop, recursive for loop, to be able to do that. Make a feedback loop, fetch feedback, and I guess we should start from the original piece, this one. Maybe this one from base here. Okay. Now, first thing first, in order to use this loops from selection, you need to select the initial edge. Okay. That means you need to have some kind of a way to select the edge initially, or for each feedback or each loop. Probably I can just do this randomly. Probably. So how shall we do this? Maybe the initial loop could be random. So in order to select the edge randomly from the input geometry, I don't know what's the best way. I don't really know what's the best way. Maybe I'll just use the attribute wrangle. Make it as a detail, then just select whatever edge inside the geometry. Okay, now how do we do that? Let's see what I did previously. I guess I could just get a random points out of those primitive, then just get the neighbor points from that point, then you get an edge. So the number of points you can get from endpoints, and the number index can be retrieved by just multiplying the randomness to this points with the seed value. The randomness is in between 0 to 1, and multiplying by the number of points will give you some index. Let's also make it as an integer. Then get this is going to be the point number, which I want to select randomly, and the next point number, let's say this is PT1. The next point number could be a neighbor point to this point, so neighbor PT1 and 0. 0 means the first neighbor point. Now let's say this is the randomly picked edge, and set edge group 0 start PT1 PT2 1. Alright, let's see, and let's try to color this with start. and see where is that start edge. Okay, right now it's right here. If I change the seed, just randomly changes. Alright, I guess that's fine. Okay, and let's make the feed loop just equal to 1 so that it will be just one loop. Just copy the whole process to here. And let's try to use that start edge group instead of just picking by yourself. Like that. And see if this is gonna work. Okay. Seems like it's working. And if I change, now this is a rather simple loop. If I change the seed, oop. Now sometimes I get really busy connections like these, which I don't really like because there's a lot of like just one pieces. This might not be a good start. Maybe I need to figure out what's the best start. Seems like I often get this kind of massive connections. Maybe it's due to this primitive. But it's really based on the if I there is kind of a no way to stop. Oh wait, maybe I can stop picking up the edge by limiting the number of steps here, but now the problem is it just stops at some random edge, which I don't think I like it. But I also don't like this condition as well. If I just pick one of the pattern, maybe I'll pick the smaller edge instead. So let's say the maximum connections will be 100. Okay, which will create this kind of a small connections, which I don't really like, but it's so in order to not to have this kind of conditions, you have to implement this node by yourself so that you can have more flexible control. But okay, so that's a little bit of bummer, but what can you do? Okay, so well, maybe I can go back later to fix this one, maybe as a post process. But for now, let's try to see if I can go with this process. Now, what I wanted to try out is to change the seed. See if I can have different starting point, and yeah, looks nice. All right, overall looks good. And then where was I? So what I wanted to do is to continuously doing this for the other leftovers. Okay, I have a bunch of questions. What do you mean by recursively? So what I mean by recursively is to do the same process over and over again than what I have done here to the leftovers, which is these one. Okay, these are the leftovers, which doesn't have a strip yet. So I'm just going to fill the strips with these over and over again until it just eats up everything. Okay. Alright, let's see. So in order to do that, might need to set some groups. So let's say I'm going to create the group called empty to the initial white geometry. Right? Then I'm going to create a split node just before connecting to a loop from selections and use empty. now the empty comes from the left, the other side comes from the right side. And the other one that's been created as a strip, I'm going to attach a group called strip. Right? So the strip comes from the right hand side. And the empty one comes from the left hand side. Right? Now this is also the, what is it? This is going to be the next empty candidate, right? Which should be added with this one. And the one that's being converted into strip, you should remove the empty group. So use the group delete and just delete empty. Okay, then all you need to do next is to, let's also name this new strip. All you need to do is to merge everything together for the next iteration. Like that. Okay, everything merged. Now, if you go to the next iteration, did it change anything? Nope. That is because you also need additional information, which is this start group for the edge. You have to pick the new start edge from this new empty geometry. So let's also try to do that. I think it might make sense to just pick an edge from one of the geometry which is touching to the border of this empty geometry. So let's create a group called group for the boundary edge. Maybe for the edges. Okay, now the boundary has been selected. What I want to do is to find the edge which is connecting to the boundary but going perpendicular. So something like this, or this, or this, or this. Okay. So in order to do that, what's the best way? Let's see what's the best way. I might also want to have another group which is for the point, which is also for the boundary, so that I can only look at those boundary points to check, to start, find the edge, starting edge. Okay. So from these edges, I just want to find the single starting edge. I'm just gonna use an attribute wrangle with the detail option. Alright. So first thing first, let's get the point numbers which has this boundary group as a point. So int pts or boundary pts is expand point group. Expand point group will give you a number of points, the point list which has a specific group. In this case, boundary. Alright. Now I'm just going to randomly pick the points from this and see if you can get the starting edge out of that. So int bpt is equal to bpts, length of bpts multiplied by randomness. Again, some kind of a seed number. Not just a single seed, but since this is a for loop, I could also use the loop iteration as a seed value, so that each loop will give you the different numbers. Okay, something like that. Then make it integer. Then hopefully this will give you the random point out of the boundary points. Now, next thing you want to do is to get the perpendicular point neighbor point. If you have picked this point, you want to pick this point, which goes from perpendicular to the boundary. So you want to omit getting this one or this one. But in order to do that, you need to check if this point is on top of the boundary or not. Okay, so you can use this boundary edge group to check. So the condition is for wait, first of all I need to get all the neighbors. From BPT. Then look for loop into this neighbors to check each of them. To see if this is on the border or not. Okay, so to check int on border, I'm gonna use a function called inEdgeGroup, which you need the input, the group name, point number 1, point number 2. So the edge group is again the boundary. Then the first point will be BPT, the next point will be the neighbor point. If it is on the order, you want to skip it, so 0, you want to use that. Okay. So in that case, the start point, I'm gonna set the start point as set edge group start BPT neighbor 1. How's that? And let's check. So where is that? Do we have it somewhere? Okay, here we go. So this is on the edge. You have an edge like this. Now if I change the seed number, I want to make sure that this goes okay with any kind of seed number. Where is it? Okay, this one's good. This one's good. Okay, this one's good. So far it looks good. So let's go with this one. See if it's gonna work. Okay, so first loop, second loop, I do see an edge being created. Looks good. Third loop, another strip being created. Fourth, and if you just increase this, you start to see strips. But the color is every color is a bit same, so I wanna change that. Gonna bring this one to the And alright. Although I want to also make the empty to white so that I can see which one's empty. Okay, so you still have some empty spaces even if you've done 100 iterations. What if I done 1000 iterations? Okay, now I think you have filled the pig head with a bunch of strips. Sometimes you have a small strip like these, which sometimes you get it. You cannot avoid it, so that's a little bit of bummer, but what if I increase this number to something 300? Still okay? Now let's go with 200 for now. And what I want to make sure is that I want to stop as soon as there are no like any candidate anymore to fill in the space. I mean, meaning no new empty space, no new empty primitive is available. In those cases, I don't really need to do the loop anymore, so I want to make sure that when to stop that. Okay, so if I look at the current loop, which is at 1000, I still have a pieces left which has been left over, which if I look at these, you can see the characteristic of these pieces is that everything is just one primitive which is not connected to any other primitive as a neighbor. So if you only have primitive that has no connections, then that might be the conditions to stop looping. So in order to get that kind of information, maybe you could create some attribute for that. First of all, you count the primitive neighbors. What was this for? This is okay. So this is to calculate the stop condition. First, you calculate the number of primitive by getting the polyneighbors. All right. Like that. Then just place it as an attribute for primitive for now. Then you get the primitive attribute called length. Yeah, 0. So if you have more than 1 for this one, equal or more than 1 for this length, then you still can find the start edges, but if you only have 0, then that's the time to stop. So let's get the maximum out of these primitive attribute by using attribute promote. For primitive to detail, just get the maximum, set it to max length. Oops. Then check the detail. Okay, so I'm going to check this number, and if this is equal to 0, then that's the time you should stop doing the loop. So I'm going to go to this for each, and there is a parameter in order to stop the loop. So I'm going to create the expression looking at the detail value from the new empty node, checking the max length value, and if this is equal to 0, that's when you want to stop. And you can see that the loop has stopped at 289 in the count, so you have omitted other 700 loops, which makes it a little bit faster for operation. Alright. Looks nice. Looks nice. Now let's check with other parameters like the number of polygons for the insert meshes to see if this still works. Okay, looks good. Maybe I can also set the parameter for the number of the max length for the strip, okay, which is set to 200 right now. So let's copy that parameter to the node controller. I'm gonna name this strip max strip length. I guess I want to make this, I want to make the maximum to 1000. Okay. Right. And if I make this to 1000, what would happen? Not bad, not bad. Well, I do have a little bit of problem right here, so maybe I might be a good idea to reduce the number after all. Okay, well, let's also reduce the number of polygons for testing, fast testing. Okay, I could also change the random seed. I could also have a parameter as a random seed, which I had set 2 times somewhere. One for the random start edge. Okay, this one. Oops. And I can just reuse this seed to the other seed. So I'm just going to copy this one and I have it right here. Paste it. Oops. Okay, now I think I am now able to change the randomness as well. Alright. Alright. Starting to get interesting, hopefully. Now in terms of creating the strip, this is pretty much it. Now the next thing I want to do is to create the unrolling part. Okay. How can we make a peeling effect to this strips? Okay. In order to do that, I'm going to use a KineFX, a rig function. Okay. Let me know if you have any questions so far. If not, I'm just gonna continue. All right. So, in order to, what I want to do now is to create a peeling effect, which I'm going to use a First of all, I'm going to convert these strips into a polyline. Then I'm going to create a rotational interaction or movement using rig attribute wrangle. Then I'm going to copy that movement or transformation back to the original strip using a deformation. Alright, so first thing first, let's convert this primitive to a bunch of lines or polygons, polylines. Before going into KineFX sections, explain the concept again. Doesn't much have a concept, it's just play that I'm doing weekly. In this week, I'm just trying to encode the geometry, the input geometry, which could be anything other than pig head. It could be like sphere or anything, and just convert it into a bunch of strips, square strips. Then for fun, I'm just trying to make it peel animation out of it. Not much concept here, just for fun. Does it make sense? Not anything practical. In terms of the artificial concept, not much. I just find it could be fun. I mean, you could also unroll it to a flat surface, and you could maybe send it to a digital fabrication machines like laser cut or paper cut cutting machines and stitch it together by yourself to create a physical object. That could also be possible because this is just a strip of squares. It's easy to unroll into a flat face, flat surface. That might be interesting things to try out. Alright, so let's see. First thing first, let's convert this into a polyline. Now, in order to do that, I want to make sure that each strip is being splitted. And you can check that by double clicking to one of the faces. And only the connected piece will be selected. And I think everything is being splitted to a strip. So that's cool. That's cool. So if you get the neighbor out of the selected piece, you only get the connections between, you only get the neighbors from the connected pieces. So if I get the neighbors from this primitive, you only get this one and this one. So knowing that, you should be able to get this edge and this edge using the half edge informations, get the middle point, connect it, create a line. Simple as that. So let's do that. Primitive wrangle. First of all, let's create that kind of conditions. Looking for the primitive, having two neighbors, then get the half edge, get the middle point, connect the line. First thing first, get the neighbor primitives. Alright, then if the lengths of neighbors are equal to 2, then you want to start looking for the half edge which have the neighbor primitive. Again, we did this kind of searching somewhere when we were looking for the starting edge, so we can just copy no, not this one, cross center, 3 center, yeah, somewhere around here. Maybe I can just copy all these and reuse some of the code that I wrote. Copy. Go back and so so getting the first half edge randomly, loop for 4 times. Okay, get the half edge, get the next equivalent edge. Then if this is equal, meaning there's no neighbor primitive, in this case, you created a edge group. But in our case, we want to look for this edge here, where you have a primitive, neighbor primitive. So the condition should be not equal, meaning you have a neighbor primitive. Then you can get the next half edge. If you're looking at this half edge, then the next half edge will be this one, and you should be able to get the starting point for this edge. But you also need this point as well, so you need 2 edge points. Let's copy this one and one for the half edge. Alright. Maybe I can just do everything inside this condition here. Right. And I don't really need to set the edge group, but instead I just want to add the line. So in order to add the line, you need to create the new points in the middle. Meaning you need to know the position for this starting point and end point. So get that information. Using Vex. Okay. Okay, that's for one of the edge. This is another edge. Then calculate the middle position just by adding 2 points together and divide it by 2. Divided by 2. Alright, finally I can create a new point. For those middle point and connect it as a line. Okay, how did it go? It's a bit hard to see because I also have the overlaid primitive, so let's remove that to see if it did work. Alright, nice. Now I still have the leftover primitive, which is the one on the edge where the neighbor primitive number is equal to 1. So we also need to create the conditions for that one. So let's think what will be the conditions in order to create the connections. In this case, before removing the primitive, so we need to create the line like this. But since we don't have any neighbors for this primitive on the other side, we need to create the other conditions in order to create the lines connecting like these. So if you have only one neighbors, then that means you're just going to use that neighbor primitive, connect it with other edges, which is pretty similar to what I have written here. Okay, so I guess you could just say 2 less than 2. That might be just fine. And there you go. Works just fine. If I remove it, every primitive has been removed, and you have a nice line connections converted from a strip. And we can use this for KineFX. Alright. So in order to use it for KineFX, let's clean this up a little bit. Fuse polypath to connect all the lines together as one polyline. So you have like 208 polylines, and it should be the same number with the number of connections or number of strips. So let's also check that. Going into a primitive, check the class numbers. And what's the maximum class? 2213. So seems like you are missing some lines, which could be the one that has only one primitive, like such as this one. Let's check if we have lines on top of this primitive. Nope, we're missing it. So I guess we want to create that one as well. Preferably if this one goes across the line, that will be great, but let's not make well, this gonna be a bit of too many conditions to search for, so just try to create the random directions, either this way or this way. Either way is fine. So to do that, that is the condition where the number of polygons, number of neighbors is equal to 0. So in terms of when the neighbor number is equal to 0, I guess we need to do something else rather than doing this. Okay, so in that case, let's see what will be the best. Well, in that case, I guess I could just say, or if the length of polys is equal to 0 and or just 0, then I can just use this hedge as it is without checking the next equivalent edge. Oops, nope. Actually, that's not a good idea because it's creating in both directions somehow. That's not really good. Just okay, as soon as it's been added, you can just break the loop and that's it. Okay, that should do it. Alright. Then the number of primitive becomes 213, which is the same as the total number of connections, which we've seen here. Cool. Or is it one number larger than this one? I'm not sure. Am I missing something here? Okay, let me see if length polys is equal larger than 0. Delete it. This will keep the single primitive. I'm gonna check if you have a line created to those places. Yeah. What if can remove Okay, okay, now I see it. The reason why this one, the total number of primitive connected pieces are a bit less is because probably the one line have connected other pieces together. That might be the reason to become a big one polyline. Okay, so I guess that's not a big problem. Let's just remove all the primitive. Okay, so now it's time to try to use the KineFX to, first of all, animate this somehow. I am going to use a rig doctor first of all in order to create the initial transformation information to each point, so we can use a rig wrangle. Alright, looking at the point, should be able to see the local transform and transform, and that's the matrix, transformation matrix you want to control over rig wrangle. Rig wrangle. Now what I want to do is to try to create a rolling effect, or how do I say, rotation effect to the strip. Looks like it's being rolled, peeled like orange. Okay, that's what I would like to try out. In order to do that, you need to figure out how what's the axis for the rotation, what will be the angle for each point, so on. Okay, so first thing first, I'm going to try to just do this manually to check if it's going to work. So in order to rotate the point, roll the primitive using rig wrangle, I can use the rotate. Get the matrix local transform and rotate it by some angle. Using some axis, rotation axis. Okay. If I increase this, you start to see that the pieces are being rotated based on this angle. But this is exactly not the things that I'm looking for. First of all, I don't really want to rotate the starting point of the primitive. So I need to figure out the specific angle for each point. Also, the axis should be equal to the perpendicular directions from each point. So that's also must be figured out. So first thing first, I'm going to create a tangent vector along the curve using orient along curve, which will create a tangent named as n, like that. these blue lines, these blue vectors are going to be the tangent, which is n. The up, I don't know what up is. Let's see, this could be the perpendicular, but I'm not sure if I can use this as it is for rotational axis. Pretty decent, but the one that I like, I'm looking for is the one that's aligning to the surface. But these ones are going up, going inside the surface. This one is going outside the surface, so not very useful. So I'm gonna recreate the perpendicular directions instead of using this one, referring to the normal of the original geometry, and try combining with the tangent vector of this curve. I'm going to estimate the rather best up vector instead of this one. So I'm gonna turn this off. Then go back to the original geometry with the normal on. Maybe I can connect this one here. So I think I can refer to this base, which you have the clean normal directions. Let me change the normal to points. Okay. So let's refer to this base to get the normal direction on the surface. There you go. Now I'm going to calculate the up vector by myself, or not, maybe not the up vector, but the axis vector for the rotation for each point. So first thing first, I'm going to get the closest point informations by using a xyz dist function. From the current point positions, you get primitive and uv. Then you can get the normal direction using prim uv from 1. The name of the attribute you want is the normal prim uv. Alright, then that's the normal you get, and now what you want to have is the one that's the cross vector between the cross product of this normal and the tangent vector of this point. So a axis is equal to cross. The tangent is currently set as at n, and this is the normal vector coming from the surface. Then calculating the normal product and normalize it, you should be able to get the tangent vector. And let's apply this to a point attribute and check. I'm going to create a new marker to visualize this axis. Okay, and if this edge or if this direction is aligning to the surface, that's what I want, and looks like this is what I want. And this is going to be the rotation axis. I'm going to rotate the primitive along with this axis, which will create the unrolling like that in this using this axis. Okay, looks nice, nicely created. Now everything is ready. Going back to the rig. Instead of just using x-axis, I'm just going to use the one that I have just created. And also for the angle, I want to make the angle based on the point position. So I am going to sort the primitive or the polyline points based on the vertex order just in case, so that the point order will be from start point to the end point. Then I'll get the first of all the primitive number out of points using point prims. This will give you a primitive number which has this point. Then get the total number of points belongs to this primitive by calling prim points. Okay, now you can search for the current index of this point inside this primitive, inside this point list, which is, I'll just call it PT, which is a what was the function? Find, yeah, find PTS ptnum, which will give you the index of this list. And using that index, I guess I named this index. Using that name as an index, you can finally create in which position the point is being placed for each point by dividing the index by the number of points. And to make sure that this is in between 0 to 1, I'm going to subtract by 1 for each index, or just this one. Alright, this will give you a value in between 0 to 1. If the value is equal to 0, then the point is in the first point, the starting point. If this is equal to 1, the point is in the end point. Right, and I'm just going to multiply that value to the angle. And there you go. Based on the position of the point, you are now rotating, you are now fixing the starting point, but just rotating the end point. Just like opening the piece, peeling the piece. Now I still don't like the effect. It's moving a bit too fast initially. So I also would like to fix that. I'm gonna start rotating slowly, then open up bigger. So the first angle should be really small, I guess, then becomes really big, or either other way around. If I make this 3, okay, let's make this maximum to 3. So initially it's rotating a bit too fast, and I also don't want to rotate these parts initially. Just want to start gradually rotating from this part to this part. So in order to do that, I think I need to create a conditions, the speed, to control the speed of this rotation. Okay, so let's think how we can do that. So I guess I could set the angle to the maximum as a parameter. Then other than this parameter, I could have maybe a slider value to control the animation. So let's give that value, how do I call this? I'm gonna create a parameter called f, which goes from 0 to 1. And using this, I would like to control this angle somehow. Give an angle as a variable. Like that. Now let's see if I just multiply f as it is and see what happens. Same as before. Now, next thing I would like to do is to try to limit the value p. Based on this f value. So based on the position of this slider, I also would like to control the range, how much range I'm going to use out of this p. Okay, sounds a bit confusing, but what I just want to do is to use a fit function for this p and use f as a minimum value, then probably 1 for the maximum for the sources, and then remap it into an angle like that. And then you start to see a bit more like what I want. Maybe the angle is a bit too far. And I might also need to add a little bit of numbers to this one. Okay, so start to get something what I wanted. Having gradually rotating the pieces. But I still see that the angle, the initial angle is a bit too high. Seems. And I want to make it so that the 0 is where you are closed. You have the closed edge, and then you're opening up by making this f value to 1. So probably I should go -1, 1 minus f. Okay. Now, next thing I would like to do is to figure out, maybe I should also change this angle, the maximum angle, gradually based on this f value somehow. So let's see if I can use fit01 for f and set the angle from 0 to the maximum. Not sure that's good. Maybe the other way around. Nope, not that good. If I just use angle, which is pretty much the same as before, and multiply this by a small number, something really big. Still not really not looking that good. What else I could do? I don't know, maybe I can just use angle as it is after all. Probably not that bad, I guess. A bit too jaggy. Alright. Anyway, I mean, doesn't look that bad in terms of the rotation. Maybe the initial gesture is a bit too big. Alright, I want to see if I can fix. Oh, maybe. Yeah, not that bad. Okay, let's try to go with this for now. And we can come back, see if I can change this, update this a little bit later. Now what I'm going to do next, it's easy just changing these polylines, but what I want to do is to feed this animation back to the original strip. Okay, I want to do the same effect for each strip. But when it comes to a strip, it's not that easy to do because the rig wrangle only works on the points or the polylines. So what I'm going to do, I am going to use the deformation, one of the deform node, to do that. Capture the conditions and deform based on those movements. And in this for this capturing, I want to capture exactly. I want to capture really precisely. So I think there are no such precise capturing node exist in Houdini, I believe. In order to do that, you need to again do some scripting. So any capture will be okay, but for my case, I'm just gonna use a simple one, wire capture. Okay, the wire capture captures the geometry using polyline, then using wire deform, you can deform that capture geometry based on the source and the goal. Okay, this will be the source curve, this will be the goal curve, and using those two informations you can deform the curve. I mean deform the capture geometry. In this case, I'm going to capture this one. Now, how do I do that? So, in order to capture the geometry, since everything is stick together, and since if I just connect this to a wire capture as it is and connect a polyline to the second input, you see a bunch of those wires trying to capture the strip all at once, which is not really ideal. Everything is being like interfering to each other, so it's not really doing well. So instead of doing everything at once, I'm gonna do each strip one by one, capturing each strip one by one. It might not be really effective, maybe there are other way, but I don't really know that. If anybody knows the effective way to capture the geometry using polyline, please let me know. But the way that I'm gonna do is this way, so I'm just gonna show it. If you know the other way, I am more than happy to hear it. Okay, so for each connected piece, meaning for each strips, I'm going to for loop do the for loop, and for each one of them I'm going to capture one by one. Okay, so in order to capture, you also need to have the corresponding polyline for the second input, which corresponds to the this primitive. And in order to get the corresponding polyline from this input, you should share some kind of informations over this one and this one. Okay, so what I'm going to do is to copy this class attribute to the created polyline so that I can refer to that class to see the paired polyline for primitive for strips. So this one, the class goes to here, and this class will be deleted at this point. So I'm gonna copy this class when the line is being created. Set prim group 0, or maybe I can just use attribute transfer for the primitive that's been created. And just copy the primitive attribute called class, and the condition, you can just remove the distance threshold, copy it from the original geometry. Would that work? Maybe not. Maybe this is a bit too ambiguous condition, so I'll just do it right here. Set prim group attrib 0 class okay. Now let's make sure that the class has been transferred. Yes. Now, after using the polypass, the class again disappears. Okay, like that. So we need to bring the class again back again. Hopefully this time attribute transfer might work. Transferring just the class. I don't need a point. And seems like the class has been transferred nicely. Alright. Hopefully this has been transferred. Then I can try to use that primitive attribute. Just search for the corresponding one. So primitive wrangle first of all, get the reference class by checking the class coming from the second input, which is this one. And then if the current class is not equal to the reference class, then remove it. Then you get the corresponding curve. Compare with the primitive. Yeah, it is. It is corresponded. Okay. So you have the nice pair. So you can have a 1-to-1 wire capture connection. Let's set the parameter to a decent number, like this one. Okay, well, I don't know if this is good enough, but let's also check the attribute throw point, and okay, so you see these conditions here, and I'm not sure if this is good or not, but let's hope this is good. And everything has been captured. Hopefully everything has been captured by this. Not sure. Let me check. I'm just gonna randomly pick the edge. If this is being captured, seems like it's been captured. Yeah. Although I'm seeing some weird negative values here, which might not be good. Well, might be okay. Alright. Hopefully this is okay. And now I can try using a wire deform. First of all, connect the capture geometry to the first input. The rest of the wires, meaning these curves which is not moving, to the second, and the one that has been transformed to the third. And something exploded. Okay, so something must be wrong for sure. Okay, so we gotta have to fix this. Okay, obviously everything is going wild. Nothing is really good. Okay, so where should we go first? If we just pick one of it, see if it's gonna work. And okay, I guess one of the reasons it doesn't work is the number of polygons on the left hand side and the number of polygons on the right hand side is different. There might be the condition like that. So let me check. So I want to make sure that there are no missing class for this one and this one. But just in case, I think hopefully there are no missing pieces, but I'm gonna make sure that there are no by doing what I did similarly last time. First of all, I can copy the function that I wrote, this one right here. Then instead of using this one, I'm going to search the number of primitive which has the class called which has the same class. So find attrib val and if the number is equal to 0, then obviously you should remove that capture geometry. So length primitive equals to 0. I want to remove it. Oops. Okay. Okay. Well, seems like the class hasn't been transferred correctly because those piece is not supposed to be removed. Okay, so that's the problem. Now I see the problem. The problem is this attribute transfer for sure. Damn it. So instead of using the attribute transfer, I'm just going to use a primitive wrangle to make it a bit more safer to transfer the class. Just gonna pick the point from the primitive. Probably just get the second one, the second point. Then get the position of that point. Then get the point, or maybe I can just use the XYZ distance. XYZ distance from the second input using this position, primitive NUV. Then I can get the class from this primitive. Then I can copy that class to your own attribute. Prim points. Okay, how does it go? Okay, so did it transferred? Nope, didn't. Okay, this one has a class. This one doesn't have a class. Okay, what did go wrong? Print points. So I got the point, got the position. I got the wait. Gotta have to get the primitive from the second input. There you go. Okay, no more removed primitive, so that should be okay. Now the capture has been done, supposed to be done correctly. And what happens now? I should get all the informations. Alright, well, something is working okay, something is working bad for some reason. Interesting. Okay, I guess that is due to how the this wire capture works. Let's look at which one is that piece. Okay, see if I'm getting the right connection. So the one that's messing up is this piece. It's this piece. Alright. So now that I know which one's messing up, let's see what's the condition here. Okay, so this is the condition. Now, this is a looped one. Like that. Now this is obviously, it's hard to capture even though you have even though the edge is being collapsed, or even the edge is being splitted, what it captures is the whole connections, and this one and this points being joined when you capture using this one. So obviously you need to figure out how to modify what's being captured here. Okay, so let's see what's the number for that. Looped one. Okay, I guess I shouldn't do this, but instead I should check the class. $197. So should the number should be equal to 197 or not. 6. Okay. So let's see how the wire goes. Okay, obviously it's just capturing like that. This whole like sphere is covering everything up, including these edges together. That's not really good. And also maybe the radius is a bit too big. Make it smaller. But still, you still have some problem here. So we need to fix some captured information here, so that it's gonna become a clean capture. Okay, so in order to do that, we need to look at what is actually the captured data. What is the attribute stored for the captured data? If you look at the point attribute, there is attribute like capture rang 0, capture wire W00, capture wire 0 W01, and it's pretty new. You see attribute with this kind of a bracket. Seems like a vector value, doesn't seem like a float value. Something else. Matrix, maybe, but I'm not sure. So I have figured out that there is a node called capture unpack, capture attribute unpack. Seems like these attributes are the packed version, and in order to be able to modify these values, you need to unpack it first and pack back again after you have modified it. So after you have unpacked the attribute, you are seeing something different. You have to specify what kind of capture you're unpacking. So we are unpacking wire capture deform information. Going back to the point wrangle, you start to see something more user-friendly. Not user-friendly, but easy to understand. This is a array of vectors, I assume, or float arrays. So yeah, probably this is the array of vectors. So I assume that you just need to modify the x value of this vector and the y value of this vector, and probably this captured index. Capture index must be the number of primitive. I might not need to modify this one, but instead I think I need to modify this one instead. And let's see what this value is about. I'm going to view that attribute to see What could that be? And let's make the size a bit bigger. Okay, it says everything is 0. Not very useful. Am I writing correctly? Wire capture data. Maybe cannot like create a informations from an array of vectors. So instead of doing that, let's try to visualize the original one, wire capture, the one that says wire capture. So just remove. Okay, now it says something. So you have two wire capture informations. One is this could be corresponding to the one that's on the x coordinate. This one could be for the y. And the third one is always 0, so we'll need to consider. So if you look at this, you have 0.7 on the edge, 0.8 or 0.79 on the edge. That's overall pretty much the same. I'm assuming these are related to the radius of this captured wire capturing. So probably how much it's been affected by these wire captures. So maybe 1 would be the maximum, 0 would be 0 percentage captured. So I guess this could be modified to 1 to just capture 100%. Okay, for the second input, for the second value, if you see it, so the spot, it says 0.9, this is 0.7, 0.9, 0.8, and it's going smaller, going from this way to right here and starting to get closer to 0, but suddenly you are having 0.7 here. Now that should be the problem. This should be equal to 0 for this side, for this primitive. But for this side, for this primitive, this should be equal to 1. Okay, so obviously you are seeing some number errors on this edge. So that, I guess that's the one that you need to fix. And to do that, you just need to do it programmatically. So let's do that. And in order to solve that problem, those numbers, I am assuming those numbers, the second numbers are coming from the UV of the original curve, the captured curve, which is this one. Okay, this curve, each curve has its UV starting from 0 to 1. In this case, this could be the 0, this could be 1. So based on those UVs, I can modify this value. Modify each point's wire capture data based on this. Okay, that's my plan. Let's do this. Okay, so how do we do this? What's the best way? I guess there are many ways, but we want to fix for each point, so I'm going to use point wrangle. Each point has this wire capture data, which I want to fix. And the first value could be 1. The second value could be dependent on this wire UV, the closest wire UV. Alright, so fix capture data. Now, first thing first, let's say how we can update this wire capture data using Wrangle. It seems like it is a array of vectors, so let's say if that's the case, testing. There you go. Okay, works. So I guess I assumed correct. You have one vectors as an array inside, and I'm just modifying that value. Now the first value could be equal to 1, assuming this is the percentage of capturing, the effectiveness of the captures. So I'm just gonna capture 100%. Okay, and for the second input, that's the key. Should be based on the UV of this curve. So how do we capture that? And I have to do it based on the primitive. So first of all, I'm going to get the corresponding primitive of this point, which is point prims and pt num 0. It could be equal to 0. I mean, if you pick this point, it could be either this primitive or this primitive. It doesn't really matter, I guess. I just want to check. Does it matter? I guess that it... wait. I guess it doesn't really matter, I guess. I think. Wait. Let me think. So once I get the primitive, I can get the center point of the primitive, and then get the closest point to the curve. And obviously the center point of the primitive is on top of the curve, so you should be able to get that UV. And from that point, from that, maybe I can get the line information where you have touched from the center of this primitive face, and you either need to get the point either this one or this one in terms of the UV. The one that's close to the original point that you were looking at, either this one, will be the point you want to use, and you can just get the UV from that, either this one or this one. So I guess you need additional information. In this case, a converted line, the one that's converted into a line. This one. This is polyline, which is just one primitive. This is the converted line, which is converted into each lines. And by converted into each lines, you'll be able to get the end point by picking up the primitive. So I can refer to that information as well. Alright, I think this should work. So first of all, the center of primitive. Okay, and then get the closest UV. So int t prim no. I guess I can just use a line as an information, so maybe I don't really need the... Wait, I do need it. So that's what I want to do next, is to get the line primitive using x, y, z distance to the third input, which is this one, using the center point position, get the line number uv. What you need right now is this line number here, and from this line number you'll be able to get 2 points because this is all line. And for each point you want to calculate the point position. I mean, you want to retrieve the point position. Convert it into a position. Calculate the distance between the one you are looking at inside a point wrangle. So doesn't look so smart, I know, but I don't know what's the other way to do. And look for the shortest distance, which is going to be the one that you want to use for the search for the UV. So if D1 is less than D2, then this position one is closer to the original position, original point position, which belongs to PT1, and you want to search for the corresponding UV from this position 1 to the actual polyline, which has the UV that you want. So search position. Search position is going to be position 1, else position 2. Okay, now you can start searching for the UV. Target prim, target UV. Again, you do the XYZ distance from second input. This time you use S position, T prim TUV, and the UV that you want is TUV.x. Okay, hopefully that's the one, and then finally apply that U to the second value of this capture data. Let's see. Let's see if I got this right. Now, where did the parameter go? Okay, I think I need to, after you have unpack the attribute, you need to pack this again. Capture attribute pack in order to be able to use for the deformation. Right, something goes wrong because I have to rename this. Okay, so let's check the number. So you have both 0 and 1, close to 0.9. This is equal to close to 1, I guess. Close to 1, hopefully. I'm not sure. It's a bit hard to see. But we can see it by checking the deformation. Finger crossed. Oh, nope. Still have some problem. Yup. Not really good. Still have some problem here. Gotta check. Okay. What's going on here? I gotta make sure I also didn't really fuse it anywhere. Because if I did that, that's also a problem. And also, probably the number here, the wire capturing, this could be the one that's saying that's the number of the captured geometry, which is supposed to be the one that's related to this curve primitive index, which is from 0 to 212. This is for some reason this one has from 213 starting from 0, so we have one more primitive exist. That doesn't sound correct, does it? Nope. For some reason. Interesting. So that might be the reason. That might be the reason. Okay, let's just gonna try to get what's the last one. So this will be the last one. And do we have that polygon? My polyline. There you go. Here. If we check this, check the class. Okay, well, this seems correct. So I guess we are having some missing class number somewhere. Not sure what that is. These numbers are supposed to be the same. Okay, there are some gaps here. Wait. Nope. I am assuming the order is being messed up here, so that might be the reason. And I also need to make sure that the number of classes here and the number of classes here is the same. So guess I gotta do the other way around as well. Something like that. Okay, the number of classes. To 13. To 13, the same. Okay. Looks correct. Okay, so probably the order of this one has been messed up when I have used the polypath. So I'm gonna make sure that it's ordered based on the class. Okay, so how's that? There you go. Oh, nope. Nope. Interesting. First of all, it's not really capturing 100%. But it does in some respect. Okay. Well, I would save point ID of the path, divide for path, remove all points from the path and keep new generated points. Save point ID of the path, divide the path, remove all points from the path and keep new generated points. To make it a bit more smoother, I guess. Okay, I guess something is not really capturing well here. Supposed to move along with the curve, but this one's not really not being captured well. So something must be wrong here. And maybe the condition written here must be something wrong. And this is really funny. What's going on here? Oh. So you still have some problem, this one being sticked. So I guess the modification that I've done here, the fix that I tried, it's not still working, I'm assuming. So let's see. I guess I could try this as it is for now. Class equal to 197. So maybe I can try to just pick that. Just try using one capture to this. So this is okay, not working obviously, so need to fix this. All right, what if I didn't really fixed it? Still has some problem. Okay, what's wrong here? So for the point, I have got the primitive numbers and get the center points, right? And get the, okay, after I have packed it, I'm gonna try move this like that, show up So okay, obviously that's wrong because this one is 0, this one is 0, but this one is 0.8. Wait. 0.00, 0.00, 0.8, 0.8. Huh. Yeah, obviously that's wrong. I guess the condition that I wrote here is not really good. Okay. Wait. I think I need to do this here, like that. Wait, well, still not good. Alright. Yeah, just a big problem, just a big mistake. Which I always do. The wrong input number. That might be the problem. Alright, let's see how this works. There you go. There you go. Yeah, now it seems to work. I mean, the wire capture is twisting the geometry, which I don't like it, but I don't know how I can fix this because this is based on the wire capture transformation, which I'm not sure how you can fix this. I don't know. Maybe I can set a normal value to the curve. That might be the way to fix. I'm not sure. Nope. You might need to fix the rotation of the curve itself, but I am not sure how we could do that. Does this work? Nope. Doesn't really fix the rotation, doesn't really do anything. Nope. Well, put that aside, I think it's working. So let's see if it's gonna work for everything. Starting from 0. Alright. Finally. Okay. Cool. Now I think everything is going fine instead of those twisted rolls, which is, I don't know how to fix this because this is based on the wire deform. I don't know what's going on inside. I have no idea if you can fix this. Probably using some information from the curve, orientation of the curve, but is it like able to fix it? I don't know. This is pretty funny, this condition here. Wire wise, I think it's fine, but primitive wise it's flipping. And if you look at the curve, if you visualize the normal, I guess it's based on the normal and probably the up vector as well. So what if I update the normal angle, normal vector value, and copy axis to up? What would happen? Same. Doesn't really change anything. Funny. If anybody know about this, please let me know. But I guess, I mean, that's fine. What happens if I make smooth? Yeah, I did normalize it. Huh, funny. Obviously this part is flipping. How's that? Is it the same if I use something like polypath? Or no, polytube, polywire? Would you get the same result? If that's the case, then maybe I can't do anything. Well, it's not really twisting. Nope. So I guess it's due to something inside wire deform. Not sure. Oh, this one. Oh, this one? Huh. Wait, this one seems to work. This looks clean. Oh yeah. So, no transformation, no local transformation seems to work somehow. Okay, that's cool. That's more like it. That's more like it. And having smooth might make sense, so just gonna put it in. Alright. So I guess I don't really need these. Nope. Cool. Nice. I guess the smooth is a bit too strong. Let's go without it for now. Still look cool. Nice. Alright. So That's for unrolling. That's for the strip peeling. Takes a bit of time to implement. Sorry for that. Especially this part, how you can modify the capture, sort it out, and so on. But I learned a lot, so that's good. Okay. Finally, I'm going to merge the peeled strip together with the base to see it, how it's gonna animate it. And also organize some of the parameters that I've created throughout the setup. Okay, first of all, I can bring the angle and this F value to the controller. So the maximum angle, the F value, on my peel ratio. Angle is angle. Probably I could multiply this by pi to make it more sense for number. What else? Axis. Really don't have any parameters on those. These are just the functions. Yeah, these are just functions. So we have rather small number of parameters in this case, I guess. Oh, it's been hidden. Maybe the base is a bit too big. I can make it a little bit smaller. Shrink it a little bit smaller so that the peel, the skin will be shown up. Just move a little bit to the negative direction of the normal distance, normal direction. Nope, not yet. I think I'm moving a little. Okay. Okay, that should do it. Cool. And right now everything is peeling at the same time. If you don't really like that timing, you could go to the rig attribute wrangle, modify a little bit of p-value here. For example, let's say P could be, I don't know, maybe subtract by some random value based on the point position. No, not the point position, but the primitive number, I guess. Multiply by some seed. multiply by, I don't know, 0.5 or something. This will change the starting speed of when the peeling starts. Some peeling starts faster, some peeling starts later, so on. And in order to make everything goes to the end, or you also need to fix some of the stuff. So goes from what if I do it like this? Oh, what the? Wow. Ah, interesting. Do I have to subtract? No, I don't think so. This should not go less than this minimum value, so that's a weird movement. Doesn't look correct. The thing that I want is to make sure that these purple go all over to this place from 0 to 1, even though I changed the timing. So what I need to do is to change the speed, how fast it moves, right? So if you have more offset, like this one, the speed has to be faster. So in order to make it faster, this is the F is just the ratio which goes from, in this case, 1 to 0. It's a bit confusing. Can I change this to yeah, so this goes to 1 to 0, going to smaller direction. More value you have, it becomes to 0. More rolling you get. Alright. Okay, that makes sense. And then there's a possibility that this goes, even if it goes equal to 1, since the P could be minus 0.5, which will give you This 0. Now this goes from 0 to 1, so in this case only the half of the rotation will be realized even if you go until 1. So you want to make it go over a 0.5 or maximum, then I guess what you could do is get that random value stored. Subtract here, get the maximum of this and this. Still not going to the end, does it? Interesting. I need to do this. Okay, that seems to work. Or not. Yeah, I guess this does work. It's going till the end. Looks pretty funny. What if I increase the random ratio to 1 or 2? Wait, didn't really change anything. Wait a minute. If I make this 0. Okay, well, then that's no good. That is no good. The initial idea is that I wanted to have an offset. This doesn't really give any offset, does it? No. So that's no good. Floating around like this, not make sense. Okay, I'll just go with this for now. Although, in this case, maybe I don't really need this. Getting confused. So if I have this, what does it mean? This offset here. That means means I might need to increase the speed here for the F. But how? Maybe not this one. I don't know. I'll just leave it as it is. Sorry. My mine is not really working well. But overall looks okay. Okay, maybe this could be parameter as well. Offset. Like the starting offset ratio. How fast it's going to start rotating. And then if I don't limit this f number here, f value here from 0 to 1, then I can just finish until the end. Maybe that's more easy to set. In those cases, I need to maximize, clump the value to some. If the peel ratio goes more than 1, like 2, gotta make sure that this one doesn't go off the surface. So in order to make sure, the TP goes over to 1. Wait, F. So this should not go less than 0. There you go. Wait. If that's the case, if you increase F like really big, there's a chance that this goes minus. Maybe this could be random. Minus random. Okay, that way should work. Okay, now I can try animating this by setting the peel ratio by multiplying, using the frame based value, like time, maybe. Was it T? Oops. Maybe a bit too fast. Something like that. 2.5. could try changing the angle. Speed. Offset to change the starting position. And then all that set, you can try out different like setups, different geometry, different number of polygons, different seed, and so on. Let's try with other geometries like rubber toy. And see if it still works. There you go. It should work for any geometry like sphere. There you go. And you could also increase the number of strips. Let's say 6,000 quad. Maybe I can also increase the maximum strip length to 1,000. Takes a little bit of time to calculate. Okay, well, interesting, but I do see some patterns here. Not bad. Not bad, but let's make it a little bit, each strip's a little bit longer by making less cross. Okay. Alright. Nice, nice. It's nice. It's more like a mustache. Okay. Like it. And seems to work well. Anybody have any questions so far? If you are here, let me know if you have any questions. If not, I think I'll just gonna finish this live stream for today. What else I could try? Pighead. Cool. All right. Yeah. Think I like it. Think I like it. It's a bit weird that this rotation conditions for these. Maybe I want to fix an angle a little bit. So I can. Let's see how I can do it. Wow. So right now, everything is using the same angle, which might be okay, but what if I multiply this by f? Oh, looks a little bit better, isn't it? By 1. Yeah, better multiply by f. If I look from here, if I multiply by 1, multiply by f, initially looks like this. Now in this case, 1 is better. So fit could be related to P then. Not so much. Not so much. Divide by V. Oops. P is okay. 1 minus P. This is rather a big gesture. It's also interesting. But not so good. It's pretty hard looking for the best. I guess I guess after all, using just a normal angle as it is fine. Seems like. Probably. Well, you can look into it by yourself, just test out. One where it can be used, I don't know. I don't know. Let me know. This is just, I'm just doing this for fun, so just to practice my, I don't know, X. I mean, I did use this for a workshop that I've been doing, but other than that, not so practical. One idea is to apply wallpaper to a wall at playback animation. Sounds interesting, yes. That sounds good, that sounds interesting. You could obviously use this for a plane, I think. In terms of plane, you don't really need to make it solid, so you could just, I mean, those, in this case, you don't really need to make it as a quad because this is already a quad face. Right. Well, let's say if I connect it here, you get, well, a diagonal piece. Interesting. What if I make it, I think the version 2 of Instant Mesh, which is available on Windows, will enable you to feed the flow curve to control the flow of the Instant Mesh. The version 1, which is available on Macintosh, is not possible to set the curve by yourself, so that's sad. Interesting. Now this one looks pretty cool in terms of the animation, doesn't it? Okay, well, I guess that's it for today. Thank you for joining today, and sorry for all the fuss that I had, especially with the wireframe capture. But overall, in the end, I think it becomes better. So hopefully it satisfied you. At least it was interesting enough for me to try it out. So I will save the file and share it with you. You can download the files from the video description page of this video live stream. Also, I'm doing a Patreon page, so you can also download from there for free. The video is also going to be archived, so you can watch it later if you're willing to watch. And that's it. Hopefully you'll enjoy it. Thank you and good night. This is 3:30 a.m. in Japan time. I should go to sleep. Okay. Good night.